Hey everybody, welcome to the Jack Atwood Podcast, episode 10, and here today I am with another very special guest. His name is Harris Taylor, and he is a lead mechanical engineer at a company in Provo, Utah called US Synthetics, and what they're doing there is, well, making synthetic diamonds. It's in the name. But our first question, what do you do and what does a normal day look like at your job?
Yeah, so as I mentioned, we got kind of that core business that supports the oil and gas industry, and where I'm at with the nozzles is a little different. It's almost like a startup within a company itself. Right. And so what that is involved is, how are we going to produce, designing the product, how are we going to produce the product, supporting the customers once that product's sold, and it's everything. Like I said, it's kind of like a startup, and my hands are in many aspects of the business, whether it's marketing, whether it's process development, whether it's quality, addressing any quality issues or problems that the production floor may be having. And so what I usually do is, touch base with our operation guys, make sure things are running smoothly, and see if there's any support that they need. And if things are going well from there, then we'll have meetings that we work on new designs, what's going to be the next iteration of the product. Interesting aspect of 3D printing market or additive manufacturing market is it's ever evolving, and it's fast evolving. And so new systems are being released all the time. In fact, today there was a leak of one of the latest systems coming out from Bamboo Lab. And so, so there'll be a whole new hot end, whole new setup for that nozzle system that we'll have to design and develop. And so if we're not helping production floor, it's working on what's going to be the next product coming out. So
have you used your degrees mostly in this job with engineering, or do you only have a degree in engineering?
So I did my undergraduate studies at Brigham University, did mechanical engineering there, and then I went to the University of Utah and earned an MBA there. So it brings in both the mechanical side, the design, the manufacturing. Then there's a whole business side of that. Hey, we've got to have a profitable business here with the product that we're producing. And so, yeah, both skill sets definitely come into this particular position here.
So what initially started your interest in engineering? When was that?
Oh, man. I don't know that there's one specific event. Just growing up, I feel like I was always designing some new contraption. I mean, I had like a chocolate milk stirrer that I made up, and we called them Harley bikes. So it's where we took the forks of the bike and we extended them to look kind of like a Harley. So just one thing over another, I was always tearing things apart, trying to design something new, make it better. So it was just the mechanical engineering route just was a natural fit. Like it wasn't even like a question. It's like, okay, yeah, that's what I'm going to be doing once I go to college.
How did you get into 3D printing? Because that's your branch of work at US Synthetics.
Yeah, right. So thinking back, kind of my first exposure to it was actually repairing a piece of luggage. Okay, so my mom had ordered a piece of luggage online, and it arrived, and the company wouldn't support her anymore. Like they just said, sorry, it's broken, not much we can do for you. And so I actually tore apart the handle. What it was is the handle, when you lift it up, it locks in place. Well, the button to disengage that lock is what had snapped. And so again, the luggage was effectively useless because that handle was stuck up. So anyways, I opened it up, took some measurements of the piece that was broken, and went to a 3D printer and printed the part and was able to fix the piece of luggage for her. That's kind of, if I think back, that's kind of my first exposure to it, and just really seeing the utility that 3D printing can have, that, all these little things around the house that maybe one little component of it breaks. Well, now you can just model it up and fix it, right?
Right, yeah.
The power of that was, a lot to me, right? And my mom saw the power of that. It was kind of funny. It was, she was actually bought a printer for me, my first printer, because of that experience. So she kind of saw the value that 3D printing had in and of itself as well.
Yeah, they're very useful devices. We actually have a 3D printer, but it's resin, one of the newer versions of a 3D printer. I would much rather prefer a filament, but with the resin, it's a lot more accurate design, but it's messy getting it off.
Each technology has its strengths and weaknesses for sure.
Yeah.
As you mentioned, the resin, for sure, the details that you can get in the end print are unmatched by FDM and other processes. But then again, like you said, FDM, you don't have to deal with the cleanup, the post-processing, things like that. So each technology within the additive space definitely has different strengths and weaknesses.
So what led to your work at US Synthetics making diamonds?
What led me to come to US Synthetic?
Yeah.
Yeah, so as I mentioned, I was doing my undergraduate studies at Brigham Young University, so that's in Provo, and all of the manufacturing done by US Synthetic is in Orem. And, there's the book smarts, the classroom learning that you get, and then there's the hands-on and real-life application in industry. And so I wanted to take advantage of that, and I got hired on here as, they call it, a student engineer. And it's really great. They work with your schedule as a student. They understand that you've got classes to attend and that. And so the schedule becomes really flexible. And so at that time, I was a full-time student, but I was also full-time employed at US Synthetic. And, that's just one aspect of the culture here that I really enjoy about US Synthetic. There was the flexibility, understanding of that circumstance as a student engineer, but allowed me to come and get experience, contribute to the company, learn hands-on what I was learning in the classroom, try and apply what I was learning in the classroom. And I actually started in what we call the automation group. So that's, if you think about diamond manufacturing, there's not a lot of diamond manufacturers out there. So you can't just go buy equipment off the shelf that can process diamonds. So the automation group here in-house produces the equipment required to process and produce the diamond. And so, as I kind of mentioned earlier, I was always making some machine or some contraption. Well, the automation group is machine design and process development, that segment of the company here. So when I saw that position come open, again, I applied for it just for that innate interest in producing machines and equipment, and was kind of my foot in the door here.
Can you walk us through how at US Synthetics you make the diamonds, like at the factory?
Yeah, it's quite a complex and involved process. So you might look at it and say, well, that's kind of simple, but there's a lot going on. There's a lot of raw materials that kind of come in together. The base of it, though, is some diamond powder, some diamond grit. What this looks like, maybe think of like the consistency of flour, but on a micro level of that, they're individual crystals, single crystals of diamond. As we take that powder and we put it in a special metal can, and then we also will often add a backing or a substrate to that diamond. And that can be various materials and metals that can be that substrate, but primarily we use tungsten carbide, and specifically cemented, cobalt cemented tungsten carbide. And that cobalt metal is a key factor in getting that diamond powder to grow together as one solid structure. So as we're talking here, polycrystalline diamond, it doesn't look like your natural gem diamond that everybody's familiar with, right? That's a single crystal that's been processed, cleaved, and shaped into that final shape that everybody's familiar with. Well, polycrystalline diamond's actually black. Probably won't be able to see it on a podcast, but I'll show it here on the video. So that's one solid piece of diamond, okay? And then what it is you've got all those tiny crystals that have grown together. So you've had diamond to diamond bond, diamond to diamond growth that occurs in the press cycle that we have here on site. And so what I was saying is that cobalt in the tungsten carbide is a catalyst that allows that diamond to diamond formation to occur in the conditions in the press. This press is probably thinking about maybe 10 feet tall. Fits back in it's got its own isolated room that we keep them in. We have over 80 of these presses on site that are running 3 shifts a day, and they're reaching pretty extreme conditions. We're going above 1,000 degrees Celsius. Wow. And over 1 million psi to get that diamond. So that cobalt will melt and then it interacts with those diamond grains and allows the diamond-to-diamond growth to occur. And so how's it made? Well, once it goes, as I just described, that press process, so we put that diamond powder in a can, put it in this large press. It only takes about 10 minutes for the total process to occur. So to get that powder to form into a solid chunk of PCD. And then everything after that is just shaping and forming the diamond, trying to get the diamond into a usable form factor, right? So as I mentioned, we got the cutters, or we have the bearings, or we have the nozzles. Each of those will have specific geometric requirements in order to be useful in application. And so there's a lot of grinding that goes on here. We have EDM, electrical discharge machining, and other various processes that allow us to shape that diamond and get it into that final form factor. But we like to, when we talk about it, we like to use the analogy, though, of machining diamond would be comparable to me giving you a piece of plywood and then handing you a 2x4 and telling you to go ahead and saw that in half and make a table out of it using the 2x4. When you machine diamond, what do we have to use? We have, for a lot of the grinding and shaping, we have to use diamond to actually get it to shape down to the final dimension. So it's extremely difficult, but it's something that we've definitely perfected and improved here at US Synthetic to be able to produce these products.
So at your factory, what exactly do you make with the diamonds? What's the final product of the diamond? What does it look like?
Yeah, so the core business, the cutters for oil and gas drilling, they have that tungsten carbide substrate, and then there's a layer of diamond, and that diamond is what interacts with the rock during drilling and is extremely wear resistant. So it just looks like a cylinder, really a simple cylinder with a couple chamfers on it. Where we start to get into more complex shapes is with the bearings. The bearings will take those cylinders and they'll be in a circular array, right? So you'll have maybe 20 of them in a circular pattern, and then you'll have two pieces that need to come together. And then the flat surfaces of the diamond is what interact with each other to create that bearing surface. As far as the nozzles, the orifice, the hole of the standard nozzle for a 3D printer is 0.4 millimeters, or about 16 thousandths of an inch. So we're talking really small dimensions here, really small sizes, right? So if you actually look at it, if you took a handful of these tips, they look almost like the mini chocolate chips. Is about the size of these parts. And so once we get that diamond shaped into the tip form, there's a whole other process and sequence to assemble them into the various nozzles. Each printer manufacturer out there has their own standard, a different thread, different pitch. Maybe it's not even a threaded nozzle. Maybe it's a full assembly that kind of clips in and bolts onto the system. So we'll have to do that assembly specific for each SKU, each nozzle that we offer.
So from the time that you have all the materials and then the finished product, how long does that process take from making the diamond? The ones for the 3D printers?
Yeah, so we could start in the morning, and by the end of the day, we could have from the powder, we could have diamond into a nozzle as a final product in a single day. Some of the other products we produce, due to the processing that we put it through, it can take weeks to get to that final specification. But if we were to just produce kind of your basic piece polycrystalline diamond, shape it, put it into the assembly process, that could happen within a single day.
So you're making man-made diamonds in a single day from just powder?
From just powder. Like I said, in about 10 minutes, from hitting the start button of the cycle to the end of cycle is about 10 minutes to get powder into a solid structure.
Wow. What's one of the biggest problems that you've had in manufacturing the diamonds?
Biggest problems. A like I mentioned, once you do start shaping, so in conventional grinding, there's a term called a G ratio. How much of your grind wheel is removed versus what you're trying to move from your stock material. And with diamond, that's an extremely high number compared to, say, conventional grinding. So essentially your grind wheel is wearing just as fast as your workpiece. And so holding really tight tolerances can then become quite a challenge, if you imagine, right? Whereas if your grind wheel's not wearing much and it's maintaining a constant size, then you can really dial in and get within tenths of thou on some grinding processes. But with the diamond, that's definitely one of the challenges that comes in when you start to manufacture.
Because you're a mechanical engineer, that's one of the biggest fields that there are. What are some misconceptions about your job in general?
About my job or engineering? Just engineering in general.
As a mechanical engineer.
Oh, that is a great question. Where I'm in the thick of it, maybe I don't have those misconceptions so much. So it's a little hard to respond to that question. I don't know, is there anything kind of coming to mind or different avenues that you have in mind there?
Well, like when someone would want a career in mechanical engineering, all these things are coming to mind. Was there anything from when you were interested in mechanical engineering and then you actually went to the courses and got the degrees that surprised you, or maybe you didn't think that you'd have to do?
Yeah, gotcha. Yeah, I think, any engineering gets heavily labeled with math and mathematics and calculus and all these different, it's going to be very heavy. And it is, right? I mean, you've got to apply those principles and methods to your work. But I guess maybe one misconception is, I don't think most mechanical engineers are daily using their calculus and multivariable calculus in their jobs, right? But what it becomes is you're equipped with those tools so that when you are ready or have the need for them, you are familiar with them and can use those tools. But yeah, if you're interested in engineering and maybe the math scares you a little bit, I don't know. I might encourage you and say, well, don't let that scare you. Proceed forward with it, despite that, as you will. With the whole point of school is to learn it and gain those skills, and you'll have that skill set with you. But it's not like every day you're going to have to be crunching the numbers. Now, as you mentioned, mechanical engineering's a wide field, so it all depends upon where you end up. But I would say a vast majority of mechanical engineering that wouldn't be the case.
Where do you see this technology of manufacturing diamonds and making diamonds in like the next 10 years, like apart from what you're doing already?
Yeah. 10 years out, that's quite a ways. I described kind of our core product being just a cylinder with some chamfers. I'd say that's pretty generic geometry. I think anything where we're going to get diamond into new applications, and right now I think diamond's very underutilized in industry and in the world, right? It's got some really great properties, not only in wear resistance, but thermal properties as well. Something not many people know about diamond is that it's a better thermal conductor than copper, better than silver. So better than all the metals out there that we would think are great thermal conductors. Diamond's better than that, and so I think there's probably a lot of applications out there where we can get the diamond into it. But the key is going to be able to shape it and get it into that final form factor where it's actually useful. So where I see our manufacturing growing and developing is in that shaping capabilities. Again. And then I mentioned earlier the tolerance and being able to hit those tolerances that the customers are asking for. From the start of US Synthetic till now, just regarding the wear resistance, it's been exponential growth in wear resistance. So with that said, is not all PCD is created equal, even though if you look at it just surface level, it just has kind of a matte black finish, looks like a little disc, but it can vary greatly in its performance and output And so I'm sure we'll continue to push the frontier on that, on the abrasion resistance and mechanical properties of the diamond. And then, like I said, getting into new applications that aren't currently in use today.
So what excites you the most about this industry, and just like what you're using, these technologies you're using to make diamonds?
So as we've talked, I primarily focus on the additive side of the business, so in the 3D printing segment. And I think what really excites me about 3D printing is how fast it's moving. Systems maybe that are a couple of years old at this point don't even compare to what's being released today in terms of speed and quality, usability. Maybe 3 or 4 years ago, I'd say the printers were more of an art than a science to be able to get something usable off of them. But anymore now, I've got a 10-year-old daughter that I'll go down and find that she's got something running on the printer that she went and found online and wanted. And so the usability of it's becoming a lot easier. And I think more and more people will be able to utilize this technology. And so that will only propel it forward even faster, again, as more and more people start to adopt it. Now, do I foresee a printer in every home in the near future? Probably not, right? It won't be. I don't think it'll be like an inkjet printer or laser printer that everybody has, but it'll continue to advance towards that way, just because as people will see the utility that it has, and it empowers, not only the functional side of things, but just even the art side and creativity side of things that people are doing with 3D printing is pretty impressive. There's some software out there where you can actually take a 2D image and it'll process it and kind of add some 3D to it, tell you which colors to load into the system. And then you can print, a portrait that's out of plastic using a 3D printer. So yeah, I think we'll see it continue to just evolve and explode as more and more people will be enabled to use it through becoming more simplistic, and then those applications will just continue to expand.
Yeah, 3D printing is definitely becoming a lot more common and well known to a normal household or person. But if you're not like designing a product, you can easily like go online and find a file and splice it and print it easily. It's being so available.
And another thing is, like, if it's a problem you're experiencing, say maybe a part broke on your car or something, right? It's very likely that same part broke on somebody else's car too, and they've already modeled it up and put it out there available for use. So,
I think most 3D printers are using plastic, but they have metal household filament, don't they?
So there is some filament that you can buy that is primarily metal powder, and then it has some plastic binder in it so that it can actually be processed through an extrusion system. It's fairly expensive right now. We're talking a couple $100 for a roll of filament versus say $20 for a standard roll of plastic filament. But then it does require post-processing, so that once it's printed, you call that in the green state, and it has to be heated, and all of that binding material has to be baked off. And so what happens is you have shrinkage. So in your design, you've got to account for that shrinkage. Then you've got to do the post-processing. But today you can get a metal part off of an FDM printer. That is available and possible. So like I said, I'd anticipate seeing more developments around that, seeing costs come down for that type of processes as well. Again, as more people adopt it, that cost will just naturally come down.
So just to get a little bit more into the U.S. Synthetics company, is it true that the whole business and campus and facility of U.S. Synthetics, it's made up of multiple factories that do different things?
Yeah, so actually before I started working at U.S. Synthetic, we kind of had departments, right? So this department would do this particular grinding process. This department would then do this assembling step. and it would just kind of step through departments and groups. And we had a kind of a transformation here, applying lean manufacturing principles. And one of those principles is to do a single piece processing, right? So instead of batching up components and then taking that batch, passing it on to the next step, you take a single part and you process it one at a time through the entire system. And so what we transitioned to were these factories, kind of you just had mentioned these factories, where each of these factories have the capability to produce product from start to finish and processing one piece at a time in most places where we can, right? Sometimes we have to batch it back up depending on the process and the requirements of that process. But the principle we try to adhere to is that single piece processing, which allows quick feedback. Are we producing to target? Are we producing good quality parts, or are we having issues? And if we're having issues, we can stop and address that before it's affected, hundreds of parts. It affects one or two parts. So there's great power in that. And that's how I mentioned a little earlier is, same day we could start from powder and by the end of the day have it assembled in a nozzle because of that single piece flow kind of mentality. Whereas if you have batching, it adds a lot of time into that processing from start to finish, because you got to process the entire batch, move it, process the entire batch, and that just compounds as you go through the manufacturing sequence.
So since you're interested in 3D printing, and one of the things that US Synthetics make is the diamond nozzles, if someone were to buy a diamond nozzle for their 3D printer, is that different from just getting it with, say, like a Bamboo Lab? Do they have to buy the nozzle after the printer, or do all printers come with a diamond nozzle from you?
Yeah, that's a good question. So, we came into this market as a no-namer, actually, right? US Synthetic played in the business-to-business sector. We were selling our product to other businesses and the oil and gas industry primarily. And this business segment of nozzles was an entirely different approach, different paradigm, right? It was a business to consumer product and something that we'd never done before. So we came into it as a no-namer and started from the ground up. And today I'd say we're recognized very broadly as in the industry as the premium nozzle offering that you can get for an FDM printer, right? So kind of the best that you can get in terms of durability, longevity, and quality. And so with that said, it's not being installed on every system that's going out, because not every user, every individual that's buying a printer needs a diamond 3D printer nozzle. Where we really shine are the individuals that are pushing the limits using those extreme materials that are available. So there's nylon with carbon fiber that's been added to add stiffness and rigidity. Well, that carbon fiber is extremely abrasive on a standard brass nozzle. So most systems, most printers will ship with a brass nozzle. Others may ship with maybe a hardened steel nozzle. And those materials will wear those out fairly quickly. As I mentioned a little earlier on the podcast, diamond is a really good thermal conductor, and which makes it stand out, even more so in this application where we're heating a nozzle and trying to transfer energy into the plastic material that's flowing through it. What it does is it makes the tip of that nozzle maintain temperature, so you get better consistency on your output. It reduces the propensity of the nozzle to clog because it's always at temperature. And so it is an aftermarket product. So we sell currently on Amazon. Again, like I said, when we launched the nozzle value stream, the nozzle product line, there were a lot of things we had to learn and do that was new to us. We'd never sold anything on Amazon before. And so there was a whole learning curve with that. But we sell through Amazon. We sell through other resellers throughout the U.S. and internationally. We've partnered with E3D out of the UK on a lot of products. They're one of the well-recognized names in the additive manufacturing 3D printing space, and we've collaborated a lot with them on different products. So if you go search Diamondback, it'll pop up and you'll be able to find it.
So what's the difference between having the normal metal nozzle between getting one of your diamond nozzles for say a bamboo lab?
What do you mean by what's the difference? Explain a little more of what you're looking for there.
If you were to buy a Diamondback nozzle from Amazon and then you put it on your 3D printer, what's the difference between the one that came with the 3D printer?
Yeah. Okay, great question. Yeah, so stock nozzles, like I said, are most likely produced out of yellow brass. Brass is actually a pretty good thermal conductor, but it is a soft material. And so if you're going to print, let's say, glow-in-the-dark filament, or if you're going to print wood fill filament, metal fill, anything that has additives into it that are going to make it abrasive, that's where you're going to want to have a Diamondback nozzle on your system. Because what will happen is slowly the tip of the nozzle will shorten. As of a standard brass, it'll shorten, and then the orifice will open as well. So then you'll just start to get poor quality prints. You'll waste material, waste time. And so with the diamond, what I tell a lot of people when I go to trade shows or just interacting with people is, if you wear one of the nozzles out, I need you to give me a call because I need to know what you did to it. So that we can replicate it here, because we've ran nozzles for thousands of hours, and there's no real measurable wear that we can see on it. And that's running some of this really aggressive, 20% carbon fiber filled filaments that are available. Maybe just to highlight maybe some other features of it. So you said, what's the difference from a stock versus the Diamondback? We internally to the nozzle, most nozzles will come. They'll come straight. There'll be a quick taper, and then it will return to another straight bore. This is kind of the geometry that you'll find on the Diamondback. We have internal tapers to the tip. So what that does is reduces the back pressure, reduces the forces required to extrude the filament. Along with the material property of diamond having a low coefficient of friction. I mentioned earlier that we've got the bearings division in our company. Well, bearings, you want low friction, and that's one of the mechanical property features of diamond is it's got a low coefficient of friction. So the geometry and the low coefficient of friction together requires a lower extrusion force. And so with the Diamondback nozzle, you can print a wider range of materials, particularly on the softer side, like soft TPUs. Maybe think of like the material that phone cases are made of, kind of that flexible kind of rubber feel material. As you get into those softer materials, they'll oftentimes bind up in the extruder gear on printers. But when you've got a Diamondback that requires that less force, it allows you to print those softer materials without running into those issues of it binding up in the extruder gear. So effectively, you get a broader range of materials you can print, from the really soft materials to the extremely hard and abrasive materials.
So how much does one of these diamond nozzles cost?
Oh, now you go to the hard question. Well, I just talked through a bunch of how much goes into processing them. These nozzles do run about $95, depending on which variant you're looking for. But again, if you think really with any of the applications that we sell into, any of our markets that we're selling diamond into, you really got to look at the total cost of ownership. Meaning, if I compare a brass nozzle to a diamond nozzle, I'm never going to buy the diamond nozzle, because the brass nozzle is going to be a few dollars, maybe $10 if you go get a name brand, where the diamond one's $95. But where it makes sense is if you're an individual that's printing the carbon fiber based materials a lot. Well, you waste one roll of that filament, and they are easily $50 for a roll of filament, right? Or maybe you've got to keep your machine running all the time, right? You don't want downtime with your machine. Maybe you're producing parts and selling them. And so when your machine's down and you have to change a nozzle out, I mean, that costs you time and money to do those changeovers. So being able to put a nozzle in, just one less thing to worry about, one less maintenance point on your printer, that's really where the value comes when bringing diamond in.
One other thing to think about is the cost of 3D printers today. And just adding an extra $95, there wouldn't be a lot of difference if you're just buying a 3D printer brand new.
It's all relative, right? If you're getting a very entry-level printer, you might be at a $300 price point. If you're getting more of a prosumer grade printer, you might be at $1,500 or so. And they go up from there, right? There's ones at each price tier. There's some at $5,000. I've seen some at $10,000. And then they go up into the hundreds of thousands of dollars. So there's a price point at every level there.
Well, just to close, if anyone is interested in to know more about US Synthetics, where can they go? Is there just like a website?
Yeah, we do have a website, just be ussynthetic.com. But I'd probably point you to YouTube. Actually, you can go on there, see some videos that we've produced in house. Talks about our culture, talks about what we produce, products we produce. We've also worked with some YouTube influencers that have essentially done a how it's made, right? So this overview of kind of talked about how diamond's made, but those videos will kind of walk through the process and show the process. It'll show the large presses that I mentioned. And so, yeah, if you're interested in learning more, I'd highly suggest going onto YouTube. You can just search US Synthetic, and you'll see all these different videos that'll pop up.
Yeah, I have seen the one video by the guy from Jerry Rig Everything.
Yeah.
It's a very interesting, straightforward process on how they make the diamonds. And I thought that was pretty cool there from just the first impression. Oh, they're making man-made diamonds in less than 10 minutes. It's pretty cool what they're doing there. It was great having you on the podcast this Monday, Harris. Loved talking with you, and I guess this concludes episode 10. Make sure if you have any episode topics you want us to talk about, make sure to email in at thejackatwoodpodcast@gmail.com. Check out the Patreon at patreon.com/thejackatwoodpodcast. You have any closing remarks and anything?
No, Jack, appreciate the opportunity to come and chat with you. Hopefully we get more people excited about the technology, about 3D printing. And like I said, I just foresee it growing and people using it in more and more applications that we haven't even imagined yet.
Okay, well, we'll see you guys on the other side.